The National Electrical Code, or NEC, generally does not permit uninsulated grounded overhead service conductors for services operating at less than 300 volts when directly connected to a building or structure. The relevant code section addressing this is 230.30a. This section mandates that service conductors entering a building or other structure must be insulated. However, there is an exception to this rule as detailed in 230.30a. This exception applies to service spans that are less than 40 feet in length and terminate on the load side of the service disconnect or meter. This specific scenario is often encountered in installations such as mobile homes, where the service conductors do not directly attach to the building structure. In these cases, the NEC permits the use of an uninsulated grounded conductor. It is important to note that the NEC provides specific guidelines for the types of insulation suitable for service entrance conductors. These requirements are essential to ensure the safe and reliable operation of the electrical system. The type of insulation required depends on various factors, including the voltage rating of the conductor, the environmental conditions, and the specific application. Some of the commonly used insulation types for service entrance conductors include Type 6 HHW, THHN, THHW, and RHW. Each of these insulation types has its own unique characteristics and is suitable for different applications. For example, Type X HHW insulation is known for its excellent moisture and heat resistance, making it a suitable choice for underground installations or areas with high ambient temperatures. Type THHN insulation is a popular choice for general-purpose wiring applications due to its good electrical properties and ease of installation. Type THHW insulation is similar to Type THHN but has a higher moisture resistance rating, making it suitable for damp or wet locations. Type RHW insulation is a traditional rubber insulation that is still used in some applications due to its flexibility and durability. When selecting the appropriate insulation type for service entrance conductors, it is essential to consult the NEC and other applicable standards to ensure compliance with all relevant requirements. Additionally, it is important to consider the specific environmental conditions and operating parameters of the electrical system to ensure that the selected insulation type is suitable for the intended application. Furthermore, it is crucial to ensure that the service entrance conductors are properly sized to carry the anticipated load. The NEC provides detailed guidelines for conductor sizing based on the ampacity of the circuit and the ambient temperature. Failure to properly size the service entrance conductors can result in overheating, voltage drop, and other performance issues. In addition to insulation requirements, the NEC also specifies requirements for the physical protection of service entrance conductors. These requirements are intended to protect the conductors from physical damage such as abrasion, impact, and exposure to the elements. Depending on the installation method, service entrance conductors may need to be installed in conduit, raceway, or other protective enclosures. The type of physical protection required depends on the specific installation conditions and the potential for physical damage. For example, underground service entrance conductors are typically installed in rigid metal conduit or Schedule 80 PVC conduit to protect them from damage caused by soil movement, rocks, and other underground hazards. Overhead service entrance conductors may need to be protected from physical damage caused by wind, ice, and falling objects. In addition to the requirements outlined in NEC, local codes and regulations may also impose additional requirements for service entrance conductors. It is essential to consult with the local electrical inspector or building department to ensure compliance with all applicable requirements. Understanding and complying with the NEC requirements for service entrance conductors is crucial for ensuring the safe and reliable operation of electrical systems. By following these guidelines, electrical contractors and installers can help to minimize the risk of electrical hazards and ensure that electrical systems are installed in accordance with industry best practices. It is important to remember that electrical work can be dangerous, and it should only be performed by qualified and experienced professionals. Working with electricity can pose significant risks, including electric shock, burns, and even death. Therefore, it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Firstly, always to energize the circuit before working on any electrical equipment. This can be accomplished by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and appropriate clothing. Thirdly, follow all applicable safety procedures and guidelines. Fourthly, do not work alone. Fifthly, if you are not comfortable performing a particular task, seek assistance from a qualified electrician. Sixthly, never work on electrical equipment in wet or damp conditions. Seventhly, inspect all electrical equipment before use to ensure that it is in good working order. Eighthly, use only approved electrical equipment and materials. Ninthly, properly ground all electrical equipment. Tenthly, be aware of your surroundings and avoid contact with energized parts. By following these safety precautions, you can significantly reduce the risk of electrical hazards and ensure that your work is performed safely and effectively. Remember, safety should always be your top priority when working with electricity. The NEC is a comprehensive set of standards that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest technological advancements and safety practices. It is crucial for electrical professionals to stay up to date with the latest edition of the NEC to ensure that their work complies with the most current standards. The NEC is not a law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. This means that electrical contractors and installers are legally required to comply with the NEC in most areas. Failure to comply with the NEC can result in fines, penalties, and even the revocation of licenses. In addition to the NEC, there are other organizations that develop and publish electrical standards, such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These organizations develop standards for specific areas of electrical engineering, such as power systems, grounding, and fire protection. It is important for electrical professionals to be familiar with these standards and to incorporate them into their work as appropriate. Electrical safety is a shared responsibility. Everyone involved in the design, installation, and maintenance of electrical systems has a role to play in ensuring that those systems are safe and reliable. By working together and following established standards and best practices, we can create a safer electrical environment for everyone. Continuing education is essential for electrical professionals. The field of electrical engineering is constantly evolving, and new technologies and techniques are being developed all the time. The electrical professionals need to stay up to date with these advancements to remain competitive and to provide their clients with the best possible service. There are many opportunities for continuing education in the electrical field, including seminars, workshops, online courses, and industry conferences. By taking advantage of these opportunities, electrical professionals can expand their knowledge and skills and enhance their career prospects. Collaboration and communication are essential for successful electrical projects. Electrical projects often involve multiple stakeholders, including engineers, architects, contractors, and building owners. It is important for all of these stakeholders to communicate effectively and to collaborate throughout the project lifecycle to ensure that the project is completed successfully. This includes sharing information, coordinating activities, and resolving conflicts. Effective communication and collaboration can help to prevent misunderstandings, reduce errors, and improve the overall quality of the project. In addition to technical skills, electrical professionals also need to possess strong problem-solving skills. Electrical systems can be complex, and problems can arise unexpectedly. Electrical professionals need to be able to diagnose problems quickly and efficiently and to develop effective solutions. This requires a combination of technical knowledge, analytical skills, and creativity. In conclusion, understanding and complying with the NEC requirements for uninsulated grounded overhead service conductors is crucial for ensuring the safety and reliability of electrical systems. The NEC provides specific guidelines for the installation of these conductors, including requirements for insulation, physical protection, and grounding. By following these guidelines and working with qualified professionals, it is possible to minimize the risk of electrical hazards and to create a safe and efficient electrical environment.